So here's a question that will require some work in Excel. We're asked to generate random numbers, okay, 100 of those, and when we generate random numbers we need to know which distribution. It should be a normal distribution with mean 1 and mean 2, variance 1. So check whether in your Excel, in the Data tab, you have a Data Analysis tab. That's what we need. If you don't have it, go to File, Options, then Add-ins, and here we need to go to the bottom of this window, go to Manage Excel Add-ins, go, and if you don't have a tick in Analysis Toolpack, then tick it, and then you will have a Data Analysis option here. Right, very useful. There's quite good stuff in here. You can have a quick look, but amongst others we have a random number generator, and that's what we need. So we want one variable, we want 100 numbers from this. We need to say which distribution, we want the normal, and we need to give parameters, mean and standard deviation of 2 and 1. Random seed, I'll tell you what this is for. I'll enter 1, 2, 3, 4. You're asked to give numbers from your student number. And output range B2, that's where we want to start. So you see from B2 onwards we now have 100 values, 100 random numbers, all of them coming from a normal distribution with mean 2 and variance 1. So for instance, we could have a look at the histogram to see whether that looks like a normal distribution. Our data in B2 to B101, okay, 100 cells. And let's just click OK. Oh, I just got the counts. Actually, let me create another histogram and create a plot as well. So do histogram as well. And I just tick the chart output. Otherwise, the same. Okay, that's fine. Okay, and so here you can see a histogram, and you can see this really looks like a normal distribution around a mean of 2 approximately. That's just to convince yourself that really we have generated normally distributed random numbers. So let's delete this histogram information again. So let's go back. What we are really asked to calculate is the sample mean, the sample variance of these 100 observations and compare them to the theoretical mean of 2 and theoretical variance of 1. But before we do that, I want to tell you what the effect of that seed value is. So let's go back to the random number generators. So usually the point about random number generators is to get random numbers. Now if I create another set of 100, I'll just let them start in C2 with exactly the same seed, I actually get exactly the same numbers. That doesn't look very random, right? But if I go back and just take that seed away, or take another seed, but you can just take it away. Actually, I don't want to overwrite, so let's start in D2. Let's put them in column D. No seed, okay. So now you get different random numbers, okay. There's the seed. If you have a seed, it basically ensures that you can always get the same set of random numbers. So if you want something that's replicable, you want to use the seed. So, but let's go back to the calculation of our sample average. So the cells are in B2 to B101, that's our cells. The sample average is 1.9898, that's the average. What about the variance? So we use var.s, we use the sample variance, and the data are in B2 to B101. And our sample variance is 1.0563 approximately. And lastly, we're asked to so let's actually first compare that to what we should expect. We should expect a mean of 2 and a variance of 1. That's from what we sampled. Okay, so we're pretty close. So now we also want to calculate the proportion of values that is smaller than 1. What we use for this is a function which is called countif. Okay, so it's countif. And the first input in here is again the range of the data we are looking at. That's B2 to B101. And then in inverted commas we say what we are looking for. We are looking for values that are smaller than 1. Okay, so I didn't set the inverted commas right. So in inverted commas, you say smaller than 1, then it counts how many we have. So 19 out of the 100 numbers are actually smaller than 1. So that's a proportion, as we have 100 observation, of 0.19, 19%. So let's just write down what we got. Our sample average was 1.9898. The sample variance was 1.0563, 1.0563, and the proportion of values smaller than 1 was basically 19%. Okay, 0.19 was the percentage. So compare these to the theoretical means and variance. We did that already. They were 2 and 1, so we are pretty close. Theoretical mean and variance were 2 and 1. That's pretty close to our sample average and variance. What about the probability? What should we expect? What's the probability that we get values of x that are smaller than 1? Using our known theoretical distribution, we need to transfer that into the Z world. That's 1 minus the mean is 2 divided by standard deviation of 1. So that's the same as the probability that Z is smaller than -1. This we can read off a standard normal table. I'm not going to do that here. I assume you know how to read probabilities of the standard normal table. It's 0.587, so approximately 16%, and we got 19%. Right, so it's not way off, but it's a little bit off. 16% compared to what we got in our sample, 19%. So now the supplementary question here is, what might happen to these comparisons if we used a sample of, if we generated 1000 random numbers rather than just 100. So let's go back to Excel. Let's generate new random numbers. So we go back to B2. We'll replace our values going down from B2, but now we want 1000 observations. Click OK. Yes, we'll overwrite the old ones. And we need to change the formula because now our values are all the way down to B1001. So we need to add another 0 in here. So now we have sample mean of 2.02 and 0.94 approximately. The countif we need to change as well. So now we got 136, and therefore a proportion of 136, or the value here, divided by 1000. So if we now compare these values, sample mean, sample variance, we'll actually see we're about as far away from the true mean and true variance and the true proportion as we were before. Perhaps we are a little closer to the proportion of values smaller than 1, but the sample mean and sample variance aren't really closer. Let's actually go all out, see whether we can generate many more random number generators. Let's try 100,000 if Excel can do it. Let's see. No, Excel doesn't like generating that many, so let's just try 10,000. Again, we'll be overwriting, and we have to change the formula to capture all our 10,000 random numbers and the proportion as well, 10,000, and we need to change this formula because now we have 10,000. And now you can actually see we are much closer to the theoretical values, much closer to the 16% and much closer to 2 and 1. So in general, if you generate a larger sample, more random numbers, you will find that the sample statistics will get closer to the theoretical statistics. Now, it didn't really happen for us as we went from 100 to 1000. That's because there's still random variation. But as we went to 10,000, this effect was very clear. So we got much closer then.